Good morning or good afternoon, everyone. This is Eric Kekola. I head up the business development team here at AWS, covering our machine learning platform. And very excited to talk to you about how our enterprise customers are adopting machine learning today to help educate all of you how you can get started with machine learning on our platform. Just a few housekeeping notes before we get started. First off, the slide deck is available to all of you. So if you click on the handout section of the GoToWebinar console, you can actually get access to the slides. So all of you are welcome to do so. And then the last piece will be questions. If you have questions as we go, please enter them into the questions console of GoToWebinar, and we'll save a few minutes towards the end to take some of those questions. So first off, the agenda. What we hope to cover for you today is essentially an overview of the machine learning and AI space. We'll talk a little bit about the history of machine learning technologies here at Amazon.com and essentially how that's informing the platform that we're building for our customers in the space. We'll take a look at how other large enterprise customers are actually using these technologies to take a look at some use cases and then customer references. And then we'll also take a look at the AWS machine learning and AI stack to help understand the technologies that we've brought to market for our customers. And then we'll wrap up with a little bit of discussion around some of the customer support activities that AWS is able to provide to our customers in this machine learning space. So first off, as a kind of level setter for the machine learning and artificial intelligence space, one of the biggest challenges is that the terms AI, machine learning, deep learning are often interchangeably used. And in some ways they are the same thing, and then in other ways they're different. And so we kind of like to start with this level setting of kind of how are the terms actually related if you kind of look at the true definitions. And so if you look at artificial intelligence, it's actually the broadest bucket where essentially AI generally refers to any sort of technique that essentially enables computers to mimic human intelligence and then use logic to actually make decisions. And then essentially a subset of that kind of very broad definition of AI would be the definition of machine learning, which is essentially the subset of artificial intelligence that essentially includes statistical techniques that enable machines to improve at tasks with experience by essentially learning on a data set. And then one subcategory of machine learning would be deep learning, which has really kind of taken off the last 18 to 24 months with some advances in neural nets. And so essentially we can define deep learning as really the subsegment of the machine learning family that's really composed of algorithms that essentially permit the software to train itself to perform tasks. Very common ones in the deep learning space are speech and image recognition. And this is done by essentially exposing those multi-layered neural networks to vast amounts of data to essentially train the model and then have it learn how to execute on those types of tasks. So we can kind of think of AI as the broadest bucket here, with machine learning essentially nested inside of that, and then deep learning as an even more targeted subsegment within ML broadly. So as we think about why are so many enterprise customers making the transition to machine learning, and why are they looking to leverage these technologies, there's really three kind of broad benefits that enterprises are leveraging. So the first is essentially in terms of automation of internal and external processes. So this is basically using these large data sets and then these models to train against the data to make identifications of how we can optimize the existing processes to make them more efficient, make them more streamlined, or just make them generally better for our customers. And then also the ability to maintain or improve our quality and cost reduction on many of these processes as well. So reducing cost is also a massive push by enterprises in the machine learning space. That second broad theme of how enterprises are benefiting from machine learning would be essentially enrichment. So this is more or less about adding new features to their current products and services, and then very specifically the ability to do things such as increase engagement with the customer base and potentially attract new customers by driving new insights about trends and customer preferences and how they can best be served by our enterprise customers. And then finally, the third part is about invention and innovation. And so this is essentially the ability to take machine learning and take deep learning and create entirely new products, entirely new categories, and entirely new customer experiences. And essentially, you can do so by leveraging, some of the industry experience and AI expertise that's already out there. We're going to talk a little bit here about some of the experiences here at Amazon.com, and you'll see that invention is a key theme and essentially how and why we've adopted machine learning technologies as well. So we'll kind of circle back to that. Then we can essentially look at some of the different vertical industries that are out there, and you'll find that machine learning is actually very broadly applicable across industry verticals. There's obviously some verticals that are leading and others that are lagging, but generally we find that there's many use cases for machine learning and an appetite to adopt these technologies across the board. So if you look at a few of the most common ones that we've kind of called out for you today, it's really quite present in retail technologies, where you see customers in the retail sector wanting to use machine learning and deep learning to improve product recommendations. Again, wanting to automate processes. So a big one within retail is basically automating customer service routing and making call centers more efficient. If you look at life sciences, essentially many of these customers in that domain are trying to do things such as clinical decision support and then automated patient routing. So again, improving efficiency of internal processes. In telecommunications, again, product recommendations and automated customer service routing are quite common, as they are in industries such as insurance. And then in financial services, many of our customers within FinServe are trying to create personalized banking applications from these models, and then also provide things such as automated advisory services. And then you'll see that within public sector, many government agencies are essentially trying to become much more self-service by using trained data sets to better serve and then optimize the processes that they provide actually to their citizens. A really good example of a customer to kind of help inform, what's possible, with these machine learning and large data sets is actually the example of FINRA. And so this essentially comes to us from the financial services segment. So for those of you that aren't familiar with FINRA, I personally didn't know them before AWS started working with them back in around 2012. But essentially FINRA is the surveillance and regulatory body that monitors every equities and options trade in the United States that happens on US soil. So essentially they monitor all of the trades that happen on the New York Stock Exchange, that happen on the NASDAQ Exchange, Chicago Mercantile Exchange, Chicago Board of Options and Exchange. Any of those exchanges that are essentially based in the US essentially provide all of their trading data to FINRA. And then on the flip side, all of the institutional traders, so things like firms like investment banks, hedge funds, etc., actually have to opt in to be monitored by FINRA. But essentially everybody does so because essentially if you're not opted into FINRA, then it's almost an admission of guilt. And so the point is that they have essentially all of the transactions from both sides of the house, and then they essentially run algorithms both in real time as the data comes in, and then also in batch workloads at the end of the day that essentially monitor for fraudulent transactions. And so this is a massive data set. They're tracking on the order of 7 billion daily market events and have over 30 petabytes of data essentially in this environment. And they essentially use their machine learning workloads to detect that suspicious activity across transactions and then be able to take action on it. So it's a great example of a massive scale customer that's running these types of machine learning workloads on AWS today. So flipping to the history of AI and machine learning at Amazon, we really have a long heritage in machine learning here at Amazon. It's a space that's very important to our various lines of business and that we've really invested in really since the dawn of the company. And so if you look at a few of those areas, if you look at kind of the first two that we've called out here in terms of personalizing recommendations and then essentially automating processes within our fulfillment centers and our inventory management, this really hits on kind of that core first theme that we called out about essentially automating internal processes. So if we can get much more accurate in terms of the recommendations that we give to customers of various products on our retail website, there's a huge benefit to our customers. And then likewise, if we can increase efficiency even by a fraction of a percent in our supply chain, there's huge benefit that we're able to reap that we can in turn essentially pass back to our customers through cost savings. So automating processes has been a massive push for Amazon using machine learning technologies over the past 20 plus years. And then in terms of the innovation and essentially driving new types of use cases, that's also very important here. I had mentioned earlier that that's a common thread in many of the things that we're doing in this space as well. So if you look at new products such as the guidance system for the drones with the Amazon Prime Air initiative, or even things like Alexa, which now allows us to actually drive voice-driven interactions, we're creating entirely new customer experiences by using machine learning and deep learning behind the scenes. And so you'll find that many of the customer experiences that people have come to expect from Amazon are actually driven by machine learning and deep learning behind the scenes. This slide's important because we want to just call out that, as we start to think about, building our capabilities for machine learning and AI, we actually want to think very holistically about these challenges and then the platform that we're choosing to support it. So as it turns out, machine learning and AI is actually just one set of very important capabilities that we need to think about. And rather than becoming, too fixated on, building machine learning and AI capabilities just because it's kind of the flavor of the day and it's for good reason. There's new use cases that are, achievable and solvable now with machine learning that weren't, say, 18 months ago. But at the same time, we want to think more holistically about what we're actually trying to accomplish, which is that we're essentially trying to create an entire data platform for our organization that essentially gives us the collection of capabilities that allow us to answer any type of question that's going to come along that's answerable with data. And so for that reason, we want to think holistically about that overall data platform, of which AI and machine learning capabilities are just one very important set of capabilities. And so we want to think all the way from products that help us to ingest the data and get the data into our data environment. And then in that second tier of orange boxes, we want to start to think about the storage tier. So everything from raw object-based storage, where we can create a data lake and a central repository for the data at massive scale and very low cost, and then up into even more specialized storage tiers, such as relational or non-relational databases. And then finally is that piece to essentially apply the analytics capability to now that we've ingested and stored the data, now we want to actually apply analytics and derive intelligence and smarts from it. And so this spans everything from traditional batch analytics solutions like data warehouses and Amazon Redshift or Hadoop clusters and Amazon EMR to now the essentially next generation machine learning and deep learning capabilities that we can apply for the data as well. So the key point here is that you just want to think holistically about, are you building that data platform that gives you all of these capabilities so that as you build and staff data science teams, they constantly have the right tool for the job. So now as we think about the machine learning and AI capability very specifically as it relates to AWS, this is essentially a summary of the machine learning platform that AWS is building within our cloud, and essentially the ways that we're investing in this platform and capability for our customers. So really, namely, there's four to three tiers of investment and platform that we're making. So basically, you start at the very base with important cloud infrastructure investments that we're making to essentially provide the best, most optimized environment for running machine learning and deep learning in the cloud. That spans up into the various frameworks that developers want to work with. Data scientists and machine learning practitioners want to work with these various frameworks to create their models and to train on data. And then into the third tier, which is platform services, so that essentially developers and customers have access to managed environments to do these things. And then finally, the very top layer, which is what we call our application AI services. And so these are essentially pre-trained models where we make functionality such as, say, facial analysis and facial recognition in our recognition product available to customers via a simple API call from a model that's basically been pre-trained and non-customizable from AWS, so that the customer has very easy access to build in that type of capability into their application. So as we take a little bit of a deeper look at kind of each of these four tiers, so what's important in the infrastructure layer and the investments that we're making there. So again, this is about making the latest and greatest infrastructure that's also most performant for things like training machine learning and training deep learning models available to our customers. So a very good example of this is our Amazon P3 instances, which were released back in October of last year. And so essentially the P3 is based on the NVIDIA Volta V100 GPU architecture, which is essentially designed by NVIDIA from the ground up specifically to run deep learning and to train these types of models. And for that reason, it's extremely highly performant for various frameworks like TensorFlow and MXNet that it's been optimized for. And it's a vast improvement over the previous, even just the previous generation of NVIDIA GPU, because again, it was made purposely for these types of applications. So you'll find that even the previous generation P2, which was an instance type also based on NVIDIA GPUs within the AWS cloud, that was only about 14 to 16 months old when the P3s came out. That the P3 actually provides up to 14x better performance. And so the point is that data scientists that are looking for the best performance for their TensorFlow or for their MXNet workloads can't find any better performance anywhere else other than the NVIDIA Volta V100s based on our P3. So we're very excited to provide developers that want to run deep learning models the best performance for TensorFlow and MXNet and Cafe2 and all those various frameworks via the P3s in EC2 in the Amazon environment. That takes us to our second tier, which is very tightly coupled with those infrastructure investments that we're making. So, in addition to having the latest and greatest GPUs and the best FPGAs for training or EC2 enhanced networking to make those clusters run together for the infrastructure layer, now we also want to couple essentially the various deep learning frameworks that deep learning developers and data scientists want to work with and want to train with. And so the approach that Amazon's taking here, which is a little bit different to some of the other providers out there, is that we're actually taking a very open approach to essentially enable developers access to all of the tools that they want to use here. So we're not basically saying that there's one tool that's the right fit for all of the different jobs and that developers should predicate towards that single tool. Instead, what we're saying is that we'll essentially enable all of these frameworks. So you've probably heard of things like TensorFlow and like MXNet and Chainer and PyTorch, et cetera. These are the programming frameworks that customers want to work with. And so our approach is to essentially optimize our infrastructure. So things like the P3 instance types are optimized for the most popular frameworks. So for example, TensorFlow and MXNet are two of those most popular ones that our infrastructure and our platform services are optimized to run with. But at the same time, we'll continue to support other frameworks that may be slightly more niche, like something like Cafe2 or CNTK, because again, we want customers to have access to all of those frameworks. The way we, there's kind of two main reasons why we do that. One is that it's very early days in this market and in this technology space, so it's very hard to understand how this space will shake out. And you see new frameworks coming along all the time. So PyTorch is a great example where 18 months back, it didn't really exist in this marketplace, and now it's arguably running, third in the market and has been very popular with developers. So there'll be new technology developments and new frameworks coming out constantly, and we want to make sure that our customers have access to those. And then secondly, we think that as the space develops and there's many good tools in this marketplace, particularly large enterprises are going to want to have access to various different tools in their toolbox so that as they tackle different types of applications, they'll have access to those. So for example, as I mentioned earlier, Cafe2 is a little bit more of a kind of somewhat niche framework here. It's not maybe as mainstream as things like TensorFlow and Apache MXNet, but as it turns out, Cafe2 is actually really good for facial recognition. So it may turn out that, at a large enterprise customer, most of the mainstream deep learning and machine learning algorithms are written in TensorFlow, but then the teams that work on computer vision want access to the Cafe tool. And so we'll make essentially access to all of these tools to mix and match, accessible to our customers so that they can have the flexibility to have the right tool for the job and then to have their environment essentially transform with the market technologies and use cases over time. This takes us into our third tier of the platform, which we call the machine learning managed platform services. So namely the main product here that's very important that we just announced at our reInvent conference back in November is the Amazon SageMaker product. So essentially, this is a hosted managed environment for building, training, and then deploying deep learning models. And so essentially, you can run all of those very popular deep learning frameworks, such as TensorFlow and MXNet and Cafe and other algorithms in SageMaker. And so essentially, what you have is really three different environments that can either fit together or be used independently. So basically, the first piece is that build component of the model. So essentially what it is a hosted Jupyter notebooking environment, which is essentially the open source based environment that data scientists want to work in to basically explore and manage their data. Is the first piece. Then the second piece is the actual training, hosting of the training. So you're able to actually have one-click deployment to go from your build environment in the Jupyter notebook, essentially into managed training, and the environment also gives you the ability to tune the hyperparameters and essentially drive the best performance possible. And the system actually uses machine learning to enhance your machine learning algorithms, and it actually makes recommendations of how to tweak those hyperparameters to basically make the models run more efficiently inside of SageMaker. And so what you find is that the training component is actually also very open as well. So it's basically based on Docker containerization. So any sort of algorithm that can run on a Docker container can actually run in SageMaker. So while we inherently have provided support for and optimized for TensorFlow and MXNet, anything that can fit into a Docker container can actually run in SageMaker. So you can actually bring a custom algorithm written in a custom language that was 10 or 15 years old, and if that can fit on a Docker container image, it can run in SageMaker. So it's providing huge flexibility for our customers to essentially run their frameworks. And then finally, the last piece is deployment. And so this is basically once we have the model trained up and we're now actually making predictions and inference out of it, we now have the ability to basically host that deployment, host that inference, and basically have an API endpoint that our applications can now call against and essentially have one-click deployment out of that train environment. So customers are using SageMaker for building, training, and then deploying their deep learning models in AWS. This brings us to our fourth and final tier, which is the application AI or machine learning services. And so essentially we have really three kind of broad categories of functionality today. So basically vision, conversational chatbots, and then language. And so again, these are essentially pre-trained models that Amazon has created and actually trained against data to do very specific applications. So if you take a look at our recognition image or our recognition video service, this essentially allows us to detect things within either still images or within video. And so namely, you can detect objects and scenes. You can also detect faces and characteristics with those faces, and then you can also detect text. With conversational chatbots, we have Amazon Lex, which essentially takes the natural language understanding and deep learning engine of Amazon Alexa and now makes it embeddable into other applications to essentially create chatbots. Then we have Amazon Polly, which essentially is the spoken voice of Alexa, which essentially allows us to translate written text and give it a voice. We have Amazon Translate, which is essentially machine translation, so that if we have, particularly a common use case here at Amazon is that we have customer reviews where a customer may purchase a product on our German website and they'll review the product there. And then if we actually sell that product in the United States, that review could potentially be very useful to someone here if they could only understand it and see it. If they don't speak German, then it's not as useful. And so we can actually now use machine translation to translate that review in German into English, and now the person here can consume it. So that's Amazon Translate. Then we have Amazon Transcribe, which is essentially the reverse of Polly, which allows you to take spoken words and then turn it into a transcription in a textual format. And then finally, we have Amazon Comprehend, which is essentially NLP or natural language processing to essentially pull out entities and keywords from text and also pull out sentiment. So a good example of customers using the application AI services. I think one last point too to make before I kind of move on to the C-SPAN use case is that if you think about the types of users internally at our customers that are using the various tiers of our stack, you'll find that there's actually a differentiation between the type of user that's going to use the bottom three pieces versus the very top. So to be very clear, that the bottom three pieces from infrastructure up through the frameworks and then even into the managed platform services such as Amazon SageMaker are very much targeted at the data science teams and the machine learning practitioners and people that are highly skilled working with data that maybe have a PhD in math and are trained in things like TensorFlow and MXNet. These are the data practitioners that want to get hands-on with the model and basically do something very granular and work with the data. Whereas the top tier, the application AI services, are actually not targeted as much at that power type of user and data scientists, but it's actually targeted more at kind of general developers who aren't familiar with how to create and train their own model. They don't know TensorFlow, they don't know MXNet. They just want to build in a common application such as facial analysis and basically get on with their job. And so if they can consume that pre-trained model via simple API calls from AWS, then they're able to build in that functionality and then get on with their job. And so that's kind of the delineation in terms of the user base across these. So coming back to the C-SPAN case, essentially what C-SPAN did is they're able to actually use Amazon recognition to tag the footage across their network. So obviously C-SPAN broadcasts what's happening in the United States government. So there's broadcasts from all of the hearings in Congress. Typically, people aren't going to want to sit through and watch hours and hours and hours of that footage, but what they're very interested in are specific occurrences, specific events, and then more importantly, specific individuals. So you may want to look up, what is the senator from your state been up to the last 2 weeks? And you can actually go to their website and basically type in an individual politician and then basically pull all of the footage and occurrences of them over that time period. And so previously they actually had humans tag all of this footage where they would basically watch all of the footage, stop it every 30 seconds, take a look at the politicians that were in the frame and then tag those names to it. And so this is, as you can imagine, that's a pretty immense effort. And they were, wasting about 9,000 hours a year in labor just doing that. And so what they're able to do now is they're actually able to automate that footage tagging with Amazon recognition. And so essentially they're able to, again, take those stills every 30 seconds of the footage. They have their own database that they've created with 99,000 known politicians, and then essentially recognition is able to match the faces in the frame, work against that database, and when there's matches, essentially tag it and automate this whole process, which again, because they're just using simple API calls into that pre-configured Amazon model that's been trained in recognition, they were able to build this application in only 3 weeks. So as we start to wrap up here, the last two pieces we want to talk about is how can AWS start to help customers in the space? So the first thing that we have to talk about is the discovery workshop. So we're really trying to help our customers to identify their use cases and identify areas to get started in machine learning, because it can be, we're trying to demystify that process for them. So we're actually able to deliver these workshops to customers as yourselves. We're essentially an AWS solutions architect, and potentially even some deeper machine learning specialists from within Amazon can come in and essentially do a 2 to 4 hour interactive session that brings together stakeholders from your side with our experts to essentially ideate on use cases and identify, how can we find some use cases that are worth doing. And so again, really the purpose of the workshop is to identify potential opportunities, share with your team how others are using ML to basically get the juices flowing on what might be applicable in your own business, and then prioritize targets for proofs of concept or pilot project that you can engage in with AWS. We also have various other resources available. So the first off is the AWS ML Solutions Lab, where we've essentially taken many data scientists and machine learning practitioner experts from within Amazon and now made them accessible to our external customers to actually help them discover use cases and actually get hands-on with these technologies and actually work on a consultative basis to help get some of those first POCs up and going. Of course, we also have the AWS Partner Network where we have many partners such as Cloudwick, Deloitte, ReamCloud, Slalom, Paravita, and Accenture, who are essentially experts in this machine learning space. And so essentially they can also come in on an advisory and consultative basis to help identify some of these use cases and get the first ones up and going. So then finally, just to wrap up, how do you get started kind of coming out of this, very kind of short, brief discussion today on machine learning. And I've kind of called out 3 different areas that we see kind of customers trending in. So that, the first point is, if you're thinking that machine learning is interesting, you want to evaluate some ways to, create some business benefit and innovate on some new processes, but you're not really sure where to get started. So you're still looking for those first machine learning use cases. Then I would point out that the AWS Machine Learning Discovery Workshop is going to be a great place to get started. And so, contact your AWS account team to see if that's something that we could get set up for you to discover and find those initial use cases. Secondly, if you've started to kind of already think about this space and you have some use cases in mind where you think you could really drive a lot of value, but you're essentially still trying to build that data science capability internally, or maybe still hire up the data science team. So you have those use cases identified, but you don't necessarily have someone who can kind of come in and write the TensorFlow model or the MXNet model. We have the Amazon ML Solutions Lab, where again we basically take machine learning experts from AWS and make them accessible to your team, anywhere from a week to 4 weeks or more, on a consultative basis to essentially build up those first initial POCs. So again, if you're interested in the Amazon Machine Learning Solutions Lab, let your AWS account team know that you'd like them to essentially nominate them in for the lab. They can take care of that process for you internally here. And then finally, if you're actually very ready to get started, if you have a data science team that's ready, maybe you just wanted to learn a little bit more about what SageMaker was and how it can run some of these algorithms. There's actually essentially pre-configured algorithms, both ones that are developed internally here at Amazon, such as linear regression for recommender systems, and then as well as open source ones such as ResNet for image recognition, which are basically just drop-in algorithms that can start training immediately on data sets within SageMaker. So a really good place to get started is to basically take those algorithms that are already configured and ready to go in SageMaker and just start running them against current data sets in current business logic. For those that are actually ready to get started and already familiar with things like TensorFlow and MXNet, that's a fast way to really dive in and get started. So that concludes the presentation. We're at the top of the hour, and we did kind of leave some space for questions and answers. I don't actually see a ton streaming in here, but if you do have answers, please feel free to follow up with us. As we said, the slide deck's available to everybody, and we're happy to engage further around any of these AWS offer things, such as the ML Discovery Workshop and the ML Solutions Lab. And then if there's any other questions coming out of today, please let your AWS account teams know, and we'll be happy to follow up with answers to those. But with that, we're going to wrap up, and thank you everybody very much for your time today to learn a little bit more about machine learning on AWS.